Hi, in this video we are going to discuss about creating and building a ROS package. Coming to the introduction, you can follow these steps by creating a ROS2 package. The step 1 is set up your workspace. The step 2 is creating a package, and third step is develop your package. Fourth step is build your workspace. Fifth step is source the setup file, and finally you have to test your package. These are the steps we have to follow to build the ROS2 package in Humble. Coming to the first step, that is about setup your workspace. What is the setup your workspace is? In ROS2, a workspace is a directory where you can organize your packages. So workspace is a directory where you can organize your packages. Packages are the basic unit of ROS software. They contain libraries, executables, scripts, configuration files, and other resources that are used together to create a ROS nodes. What are the ROS nodes? We have discussed in detail in another video. After completion of this, you can go through that. What is a nodes? Coming to this setup your workspace, the commands provided are used to create or navigate to workspace directory. What are the commands are provided here? By using these commands, we can create and navigate to the respective workspace directory. Here the first command is mkdir, that is called make directory. This command creates a directory named ros2 underscore workspace, that is a directory name in your home directory. The tilde symbol represents the home directory. Within this directory, it creates another directory named src. Src is nothing but a source. How it is created the directory inside that ros2 workspace is by using the parameter called -p option tells make directory to create any necessary parentry directories, ensuring that the command succeeds even if ros2 workspace does not exist yet. If you want to create a single directory, no need use of a -p. -p directly you can use mkdir ros2 underscore workspace. If you want to create a parent directory and all, you can use that -p parameter. And coming to the second command here is cd tilt root ros2 underscore workspace slash src. This command changes your current directory to the source directory within the ros2 underscore ws directory. This is where you will typically place your ROS packages. The ROS directory conventionally contains the source code of your packages, although you can organize your workspace differently if needed. By following these commands, we can uh, create a workspace directory structure that adheres to the standard ROS2 layout, making it easier to manage and build your ROS2 packages. So that is about set up your workspace. That is the first step. Coming to the second step, that is called create a package. How to create a package in ROS2? The command ros2 package create. What is the command I am showing here? That is called that is a command used for creating a package in ros2. Uh, the command ros2 package create a build type and amend cmake your package name is used to create a new ros2 package with a specific build type and given the package name. What is a specific build type here? The cmake represents supports the C++. If you want to implement a node programming in C++ language, you have to build the package using the build type called cmake. If you want to implement your node programming in Python, you can use py amend underscore py. That is what is a build type. Amend is a package in ros2. What is a let's break down the command one by one. ros2 package create. What is a ros2 package create is this is the main command used to create a new ros2 package. It is followed by various options and arguments that specify the details of the package being created. That is about ROS2 package create. Coming to the build type amend CMake. This option specifies the build system to be used for the package. What is a build system? Is here is a amend. In this case, amend CMake is the specified, which is the build system used in ROS2 for building the packages. If you want to build the package in Python programming, you can use amend underscore py. It builds the package in a Python. It is based on the CMake and it's part of amend build system, which is a standard build system for ROS2. Next, coming to the your package name. What is the your package name here? This is the name of the package that you want to create. Replace your package name with the design name for your package, that is as a user wish or programmer wish. The package name should be follow ROS naming conventions and typically uses the lowercase letters and underscores. For example, my underscore robot underscore control. That is a naming convention of the ROS2 operating system. You have to follow that convention. The name and all as a user wish or a programmer wish. That is about the command to create a package. Now, when you run this command, ROS2 will create a new directory that is with a specified package name in your current workspace src directory. Inside this directory, it will generate the necessary files and structure for ROS2 package, including the cmakelist.txt and package.xml files, which are essential for building and configuring the package. I'll explain in detail about the txt files and xml files, cfg files in next video in simulation part. You can then proceed to develop your package within this directory. That is about how to create a package. Now, the next one is develop your package. What is a develop your package? It refers the process of creating the functionality and components within your newly created ROS2 package. What is that newly created now ROS2 package here is, for example, the steps here, navigate to the newly created package directory. What is this? After using the ROS2 package, create command to generate a new ROS2 package. As we discussed in the last slide, ROS2 package create, which is used to create a package. Clear? After executing that command, you will find the directory with the name of your package has been created within your workspace source directory. How can you find the source directory is use the cd command to change your current directory to the newly created package directory. I will explain this part in a simulation video. Now, coming to develop your package according to your requirements. Once inside the package directory, you can begin developing the package according to your specific needs and requirements. Means this is typically involves creating the ROS nodes, which are executable programs that performs various tasks within the robotic system. You may write code in programming languages such as C++ or Python to define the behavior of the nodes. And coming to the configuration files, what is the configuration files consist of? ROS2 package often include the configuration files that define the parameters, launch files, and other settings necessary for the proper operation of the package. These files are commonly used to configure the node parameters, remappings, namespaces, and other ROS related settings. That is about develop your package. Coming to building workspace. What is a building workspace here is the process of compiling the ROS2 package within the workspace and resolving any dependencies that they may have. And what is this cd ROS2 underscore os and ws and colcon build? Coming to the navigate to your workspace. For example, navigate to the workspace, you're going to use a command called cd, okay, change directory. Before you can build your workspace, you need to change your current directory to the root of your workspace. In this case, the workspace directory is assumed to ROS2 underscore WS. It is in the home directory, which is a directory created earlier to organize your ROS2 package. And what is the second command here is a callcon build. Use callcon build to build the packages. This callcon is a build tool commonly used in the ROS2 to build the packages and resolve the dependencies. The callcon build command used to initiate the build process for all the packages in your workspace. So it will automatically detect the packages within your workspace, compile them and handle any dependencies between them. This command will compile your ROS2 packages and generate the necessary build artifacts such as executables and libraries. It will also resolve the dependencies by fetching and building any required external libraries or packages. After running this callcon build, your ROS2 workspace will be built and ready for use. Any errors or issues encountered during the build process will be reported in the terminal, allowing you to address them as needed. Once the build process is completed without errors, you can proceed to use your ROS packages for development, testing, or deployment in your robotic system. That is about building your workspace. How to build the workspace here? By using the callcon. Next, coming to the source the setup file. What is the source the setup file means? The process of configuring your commands like in the command line environment to use the ROS2 packages that you have to build in your workspace. After building your workspace, this step assumes that you have successfully built your ROS2 packages using the callcon build command as described previously in the last slide. Okay, source the setup file. What is the source the setup file here is ROS2 provides a setup file that is nothing but setup.bash that setups the environment variables required to use the package and build in your workspace. The source command is used to execute the commands in the setup file within your current shell session. What is the command here is source install slash setup.bash means this command tells you shell to read and execute the commands in the setup.bash file located in the install directory of your workspace. When you are build the package using the callcon, the install directory is created. I'll show in the simulation video how this install directory is created, how we can change our navigation to the install directory and how we can source that install and set up the bash. Clear? These commands typically set environment variables such as the ROS package path and Python path and other point to the locations of your built-in packages and libraries. By sourcing the setup file, you ensure that your command line environment is correctly configured to use the ROS2 packages you have built that. This allows you to run the ROS2 commands, execute nodes, and use other ROS2 tools without encountering the errors related to missing packages or libraries. It's an essential step to ensure that your ROS2 workspace is properly set up for development and execution. And the last step is test your package. Testing your ROS2 package is crucial for identifying and resolving any issues or bugs, validating its functionality, and ensuring its reliability in real-world scenarios. By running nodes, launching launch files, and performing necessary tasks, you can thoroughly evaluate the behavior and performance of your ROS2. Thank you. In the next video, we'll do the simulation how we can create a source file, how can we build that using the callcan command, and I will see that and how the .xml files .configuration files are created, how we can source the package. Okay, thank you. We'll meet in the next video.